Hey guys, it's Sam with Lit, and I'm here to give you guys a sort of long-term review of my Tevo Tarantula 3D printer kit. Now, the Tevo Tarantula is a DIY kit which comes in pieces that you have to assemble to produce your 3D printer. Other printers are out there that come in a ready-to-go form factor, such as the DaVincis and the Micro M3D printers. But the Tevo is in the do-it-yourself kit line. The Tevo Tarantula has a bunch of competitors: the Tronxy X2, the ANET A8, and lots of other similar, the G-Tech i3, and all of these are really clones of Joseph Prusa's i3. Now, the i3 clones are all fairly similar, and I'll go over some of the pros and cons to all of them in a bit. But I just wanted to start off with the Tevo Tarantula itself, as it is my second 3D printer. My first 3D printer was the Micro 3D by M3D. Now, the Tevo Tarantula costs about $180 to $200 currently from GearBest and AliExpress. And right now that only comes with the base kit, which is the 200 by 200 build platform, the normal extruder, no options for any dual extrusion, no options for any of the larger beds, and no auto leveling, which was all options included during the time I purchased mine. The time I purchased mine was over the holiday season, this past holiday season in December, and there were crazy sales going on with tons of options, and the prices were a lot lower. But now that the holiday season is over, the price seems to have stabilized at around $180 to $200 for the kit. Now, the pros and cons, just to go over a few of them. The major pros that I've seen from the Tevo Tarantula include the build accuracy. And so compared to older generation printers, the Tevo Tarantula is way more accurate with a good frame. It's got a solid aluminum extrusion frame, which seems pretty stable. It's quiet because of the V-slot wheels, and there's very good functionality. The board has a lot of ports, it has end stops, and has a lot of capability. The Tevo Tarantula also comes with a heated bed, which is kind of the standard nowadays. My first printer did not come with a heated bed, so printing ABS was very difficult, and I almost exclusively printed with PLA. But with a heated bed, that enables you to potentially print ABS pieces, although you still might have some trouble due to warping if you don't have an enclosure. Now, the Tevo Tarantula does have upgrades available. Whether or not when you purchase them, those options are listed, there are upgrades available for the Tevo Tarantula. Some of these upgrades include an auto leveling sensor, such as the BL Touch, although they might use some clones. You can have other extruder ends. You can have a dual Z, which I'll touch upon a little bit later. And there are some other upgrades for a larger print surface, which adds another 80 millimeters to the Y-axis. Another pro to the Tevo Tarantula is its community. Now, there's a large Facebook group where just about anything you ask will be answered within minutes. Another pro to the Tevo Tarantula is the two extruder ends that are included. You have a normal extruder, which is the blue and gold clamps, and then you have the Titan clone. Now, I'm currently using the Titan clone, and I have not used the base extruder, but I've really had a good experience with the Titan clone, and I'm using it in Bowden configuration, which means you have the long Bowden tube, the PFTE tube, going to the extruder hot end, and the extrusion happens, the extruder motor to be located off of the print carriage. The Tevo Tarantula kits come with 2 sample filaments. Now, they're quite small rolls, but there are enough to get a few small projects going. For example, printing a duct fan for part cooling, and a couple other possible upgrades or reinforcements, which I'll talk about more later. The Tevo Tarantula also comes with an SD card and the LCD mount. Now, the LCD mount is a display, but it doesn't actually mount to anywhere on the printer, and is just attached by the 2 ribbon cables to the main board, which is an MKS base 1.4, but it doesn't seem to be the official one. Looks like to be a clone of that as well. A few cons with the Tevo Tarantula. So there are open power supply connections, and it just doesn't make it very safe. On top of that, the power supply is just at an on state when you plug it in, so there's no power switch. And that, in addition with a lot of just terminal block screw down connectors on the main board, makes it a little bit dangerous. And the loose cables just make transporting it very difficult. Now, there is a little bit of bed flex. The Y carriage uses an acrylic mount for the frame, which the heated bed is then suspended by bolts and springs. But in most configurations, most ways that people have installed them, I would say that the left side, if you're looking at the machine from the front, the left side here tends to be expanded more, and this side on the right is compressed a lot. On top of that, the acrylic piece just flexes and bows and doesn't make for the most even surface quality on the heated bed. Next comes the instructions. Now, the instructions aren't that great, but it does come with a booklet, and the booklet looks pretty nice, but unless you've built kits before, you'll really get lost. It's not like a Lego step-by-step instruction, and there leaves out a lot of steps. So what they do is actually they point you to an online YouTube series where the YouTube videos will go through each individual nut and bolt and screw turns and everything to assemble your printer. Now, without this, I would not have been able to assemble my printer, and so just having that really helped. One disadvantage that's very interesting about the Tevo Tarantula is the Z-axis. Now, the Z-axis motor is actually mounted on the top of the frame and connected with a spring coupler that pulls up from here. It pulls the bed up. Now, this causes the spring coupler to be stretched out, which really isn't the best design, but it does potentially reduce backlash. But the problem is, it's not great for the spring and can potentially cause issues, wear issues. So a lot of people, what they do is they invert the Z and they actually have it push up, where spring couplers are supposed to be compressed, not fully expanded. Speaking about the Z-axis, there's only one motor for the Z-axis. A lot of the cheaper kits, including the ANET A8, which is $40 to $50 cheaper, use a dual Z. Now, the problem is, with the dual Z, if it does get messed up or out of alignment, which does happen on occasion, it's much more difficult to fix than if you had a single Z. Now, the ANET A8 comes with actually 2 Z motors, while the Tevo only has 1. Pros and cons to that is for the Tevo to have 1, it's much easier to fix an issue if one gets messed up. But if you have a dual Z configuration, if one side is misconfigured to the other side and goes out of calibration, which happens on occasion, it's a lot more difficult to fix. Now, there is also a third option for dual Z, which uses a single motor with a belt system that drives both rods. Now, it is a little more expensive because using a belt and pulley system gets a little more complicated and is a little more expensive to set up, but there is another option. I've already talked about the loose LCD screen, but it is kind of a con for me, because while you can carry the printer by itself, with one hand, it's difficult to carry both the LCD and the power supply with the other hand and have to go anywhere. For example, if you're transporting it, you usually need one hand to open the door of your car or your trunk, and it's very difficult to do with the Tevo Tarantula. I've tried to do a balancing act where I put the power supply here with the LCD here, but it really is unbalanced and falls off, and you're going to be very sad when stuff falls and breaks. So yeah, I've seen a lot of designs where you can mount the LCD on top of the carriage, on top of the frame, not the carriage, but it still makes the power supply loose. Finally, the last con I have for the Tevo Tarantula has to do with the end stops. Now, the end stops are the small micro switches that tell the printer where to stop before stopping the stepper motors from just slamming stuff and breaking stuff. Now, the Y end stop is located in the back, and the X end stop is located on the carriage to hit this little edge here, and the Z is actually attached to the frame, which then when this comes down, it touches the end stop. The problem is, with the end stops, the connectors are so poorly soldered and fragile that any sort of movement, if you're moving the printer around, or sometimes just even knocking the printers from jostling around from the printer moving, breaks those ends. Now, it's very difficult to know when the end stops have broken and don't work until something breaks. My first issue was the X end stop was not working, so it would just crash and make horrendous noises until I figured out that was the problem. That wasn't too bad, because all that really did was maybe wear out the motor a little bit, but made a noise. The Z end stop was a lot worse, because when the Z end stop stopped working, the bed kept going and it crashed, and then it broke the bracket on the top that was holding the stepper motor and just smashed it up, preventing me from making any more prints. Luckily, I had access to another printer that I was able to use to print a replacement bracket, but this is a huge problem. So, how to fix the end stop issue? You have to resolder all of the end stop connections. Don't think that you can get away with not doing it, because that's what I did, and I made a huge mistake and a lot of stuff broke. Next, after you have resoldered the connections, hot glue all over those connections to just give it a little bit of protection, and that will give some strain relief to prevent those connections from breaking again. Now, I'm going to go over a few fixes for the problems for the Tevo Tarantula that I haven't already mentioned, which is the open power supply. You can print covers and things like that, and you can install switches if you've got some extra switches, or purchase some and solder them in the wires, and add a fuse. That's also a good idea. But there are a lot of designs out there, so where do you start? You know what? This is not something I can exactly tell you, do this or do that, but I highly recommend you get one of these solutions to prevent open wiring. Also, I highly recommend using spade terminals or ring terminals wherever possible to also reduce the danger of open electric circuits. Now, the flexible print bed. Flexible being a bad thing. So the acrylic print bed mount can be replaced with aluminum pieces, or you can print, there was a design on Thingiverse where you can print a new carriage, and it looks really cool, but I had access to aluminum and aluminum sheets, an eighth of an inch thick, so I was able to just machine a new carriage. Now, the cool thing about the Tevo Tarantula is all the upgrades that you can do just by printing new upgrades. One of the upgrades I highly recommend you do is a part cooling fan. Now, PLA is the easiest thing to print with, and it is really, really easy and great, has a lot of potential. So the best thing to do is to get a part cooling fan for that PLA for overhangs and for accuracy. Now, there are two potential fan types that you might want to use. One is the normal box fan, which is just a square, and such as the one attached to the hot end, that type of fan, or the one attached to the motherboard to cool it. Those are the box type fans, the normal ones, the 40 millimeter and 50 millimeter variety. Then you have blower or radial fans, which are computer type fans, which blow out a small square on the horizontal side. Get some fans for part cooling. Whatever you have access to, just start with that. And if you do decide to get something later on to adjust, go ahead, do that. It's easy. and requires very little skill to swap those out. So a lot of people ask what upgrades are essential, which ones are suggested, and which ones can I just forget about. I would say that getting an external MOSFET is on the higher end of that. You definitely want to get an external MOSFET if you're printing at ABS temperatures. Now, I had my heat bed connector melt because it was trying to print at ABS temperatures for hours on end. And with an external MOSFET, which I've now gotten, I have no worries of that. And I resoldered the connections instead of replacing the connector. But the external MOSFET will alleviate any potential melted connectors or hot connector ends. Auto leveling. Now, auto leveling, I would say, is in the middle category, where if you're printing a lot of ABS, I would highly recommend using the BL Touch or another auto leveling sensor like a clone. If you're printing just PLA, I would say it's not as important because the PLA just sticks better to the print surface. But if you're using glass, I recommend, or if you plan on using glass, highly recommend getting that BL Touch or auto leveling sensor. It'll make everything just so much easier. And if you want to swap in or out that glass, it's almost a necessity at that point. Talking about glass, we have borosilicate glass. Now there are lots of different options for glass, and if you want to really cheap out, you can buy a dollar store picture frame and cut that or use that, but oftentimes that glass is so thin, I wouldn't trust it. So just spend the money, get some borosilicate glass, and use that. Make sure when you buy the glass it's the appropriate size, because if the glass is not as big as your print area, you might have some issues where the print head will crash into binder clips or whatever you're using to hold the glass onto the print bed. As far as the dual extruder goes, I don't think it's essential. I think using two compounds, especially at this price point of around $200, is very extraneous and kind of should be reserved for stuff that's a little more expensive or has more capability than a smaller printer like the Tevo Tarantula. So I would rate that in the lower category. Not really necessary. Now, the last one I want to talk about is an upgrade that I haven't actually used or implemented, which is Octoprint. Now, what Octoprint is a program or an operating system running on a Raspberry Pi, which has wireless capability that will connect to your printer. You can use it for recording video, time lapses, remotely controlling over the internet, your printer, and a bunch of other cool things. Now, depending on what you want to do with your printer, if you want that video, if you want to be doing YouTube with your 3D printer or something like that, Octoprint might be a good investment. For me, unfortunately, because I don't do too much remote printing where I just leave it or go away, I don't think it's very essential for me. Lastly, I just want to talk about some extra bits and pieces that you might want to purchase for your Tevo Tarantula. Now, the frame here, the 2020 extrusion, is very customizable, and you can add tons of add-ons. For example, you can do LCD mounts. You might be able to figure out a creative solution for the power supply to mount that to it, as well as potential uses of bolting down a base using wood, plywood, or aluminum or something to just bolt down and add extra stability to the frame. But what you really need is a ton of M3 and M4 bolts, as well as the T-slot nuts. I would start out with 20, 30 T-slot nuts and go from there. Just a couple last minute thoughts that I had with the Tevo Tarantula include a spool holder, which this does not include. There are a few designs out there on Thingiverse, but what I would recommend being careful of is designs that have the spool on the carriage itself, because some of those designs may not correctly account for the V-slot wheels going up and down, and may in fact not be designed properly. So take a careful look when you are getting any of those type of mounts. Otherwise, a standalone mount may be a good idea. And also with the Tevo Tarantula, cable management is very, very important. Now, this looks super neat, and I wasn't able to get my Tevo Tarantula looking anything like this, especially because this top part, I don't know how they got it to stand up like that, but mine droops sideways and comes down, and so it's very annoying. As well as all these neat wires, I don't know where they're all going. It's missing a ton of stuff here that's not plugged in, that will be all rat's nesting over here. So cable management is very important, and be careful of that. All right, so just wanted to give you guys an idea of my experiences with the Tevo Tarantula, and overall I really like the printer. It's quiet, it's smooth, it's accurate, the capabilities are very good, it's very customizable, and it's very, very affordable for what you're getting. It has a lot of capability, and I think this is a great printer to start out with. Now, the only thing is, if you are not a tinkerer, it's not probably the best one for you, because I've spent hours and hours tinkering around, fixing problems, solving solutions, most things that I cause myself, but there are a lot of issues that you might come across. So if you're not a tinkerer, if you're not comfortable with soldering and electricity and stuff like that, I would probably get a ready-to-go solution, and probably not get a kit to start out with. Now, I really want to do a comparison between the Tevo Tarantula and something like the ANET A8, which is a lot closer in comparison than my original printer, which was an M3D Micro. Now, the M3D Micro was a ready-to-go solution, 2-3 years older than this kit, and the technology was a lot less. It didn't have a heated bed. It used threaded rods instead of lead screws, yeah, it just wasn't very smart. It had its own proprietary software. Instead of using Cura or any normal G-code, which potentially had that capability to import G-code, but I never got that working. So yeah, I hope you guys check out some of my other videos, and stay tuned. Hopefully I'll have some more videos coming out later.